Alright, so today we are working on radicals 7 and 8, rationalizing an irrational denominator. To be honest with you, I know this can start to get confusing. As long as you continue following the rules, it becomes easier. It just becomes routine. It's kind of like a brain teaser a little bit that you just have to continually think, what am I doing? And if you follow the rules, there's no set what you have to do first. Just obey the rules of math and you'll get this to work. So, on the very first one, I'm going to tell you what I did different. I don't like it being the square root of 2x cubed times x. I like to break it up. Oh, maybe I'm fine. So, I'm going to show, well, I'm going to take this and I'm going to break this up. So I'm going to make it the square root of 2 times, and instead of the square root of x to the third power, I can tell right away that that cannot become a square, right? I can't square it. But what do you do when you have an odd exponent? We break it up. So I'd make this like x squared times x, square root of x, and then I still have this x. So I'd say times x. So this is how I like to show my work. If you can do it a different way, you still get the same answer, do what's most comfortable for you. I use a lot of room when I show my work. My next step is I simplify what I can. Square root of 2, I can't do anything to it. That's going to be done. Square root of x squared becomes x. Square root of x stays the same. And x stays the same. Okay? I'm going to draw a line here. I am now going to multiply like terms. I'd have x times x, which is x to the second power. And then I would have square root of x times square root of 2, which is square root of 2x. Questions on that? Okay, go ahead and do number 2 since this is warm-up. See what you get for an answer. And then I'll go ahead. This one should be really easy, to be honest with you. You go ahead and work it, and then we'll talk about it in just a second. So, the square root of 1, let's say y. Square root of 1 over y squared. Okay, what should this be? This one shouldn't take long at all. Yeah, square root of 1 is 1. Y squared is y. Okay, so today our goal is I will rationalize the denominator. I will simplify a radical expression containing fractions. Sorry, I got to turn the fan off. I will turn it back on because it's warm and humid in here. Alright. Simplify each radical expression. To be honest with you, there's not much difference here. Use what we know. Okay, who can tell me how do they think they'd go about solving number 1? Katie?
I multiply 7 squared and 2 both 7 squared.
Okay, so we have a radical in our denominator. I cannot simplify. I always look to simplify anything first, and I can't. So I'm going to multiply by my square root of 7. And that leaves me with just 7 on the denominator and 2 times the square root of 7. Now, can I simplify anything now? No. I can't simplify. Nothing left to do, so I am done. Number 2, just for spacing, I'm going to show my work down here. Okay, what should we go ahead and do first? So our first step to solve this, David?
Multiply the numerator and denominator by the square root of 6.
Alright, so I get the square root of 30 all over 6. Girls, let's pay attention, please. So what do we do next? Are we done? Yeah. So I'm going to look at when I have the square root of 30, what can I break that into? Okay, does that do anything for me though? Does that do anything for me?
2 and 15.
Okay, does that do anything for me? Good. There is no perfect square in the square root of 30. None of 30's factors are perfect squares. So I can't do anything here. So, we're done. Now that's pretty tricky sometimes. Because we know we can simplify this because we can factor it down, but remember it has to be of a perfect square. Okay, number 3. Pretty simple. That's what we want you guys to see. Instead of doing that extra work of times it by the square root of 6 and stuff, if it's the same number above each other, it just equals 1. That one's pretty straightforward. The reason we're showing you that is because it's going to come up here very soon. Now, this is the one I knew some people had troubles with. The division. And the reason was we were really we didn't break it up and we tried to just do the division with one of them. But when we have this radical, what I need to look at is this is going to be like the square root of 5 divided by the square root of 5 minus 3 divided by the square root of 5. That dividing by the square root of 5 is going into both of them. So, what would this simplify down to?
1 minus 3.
So that's 1. But then this one, I'm going to show my work over here. I can't have that. So we get 3 times the square root of 5 all over 5. And we had a 1 in the first part. And then we have this. So I can have 1 minus 3.
It was multiplied by the square root of 5. And then just make that 5 minus 3.
Right.
Mm-hmm.
Why didn't you just multiply it by the square root? Like that. Why didn't you just multiply it by the square root of 5 over square root of 5? So that it's 5 over the square root.
I got it.
I mean, from the very beginning.
Yeah.
If you did that,
Oh, yeah, that makes sense.
It'd be 2 over 5.
there's a reason why can't we? If you did that, why would that come out the same? You're saying a few times by the square root of 5 at the beginning.
Yeah, the square root of 5.
So then I would have done square root of 5 times square root of 5. She's done 5. But I couldn't minus, I wouldn't be able to minus 5 minus 3 because the 3 is being times by the square root of 5. Because if you times it by this, you would end up having the square root of 5. Oh, you shut it all the way down? Alright, I'm going to repeat myself so it's on video. So, what we were saying, when we are dividing, and I'm dividing by this square root of 5, in my numerator I have an addition subtraction, which means I have 2 terms. When you have multiple terms, your division has to go into each term. Okay? You cannot just simplify and get rid of the denominator on one term and not have it go into the second one. So that's why we're showing breaking it apart. Let's see if we can do it on number 2. So, honestly, when I see this, so I don't make the mistake, is I break this up into 2 problems. I see that, and then I see that. So I would say I have the square root of 11 being divided by the square root of 11 minus the square root of 13 divided by the square root of 11. Solving this, well, we know this first one is 1 minus. And to get this alone, we have to times by, and that will become 11 over, I did this last time, what is it, 148? 143? Oh! What did I write that for? No. Never. I did 146. Failure. Alright. Square root of 143. Now that looks pretty big. Are there any factors of 143?
No. I mean, yes.
None that are perfect squares. So I'm done. And this part is going to come over here. About to do it again. What? What'd you break it for? Alright, so that's the end of lesson 7. You're doing the same thing. To be honest with you, it's nothing too different than what we did yesterday. Alright, let's look at lesson 8. Remember, we're doing 2 lessons a day. These are short. And if you guys stick with me and we get through these, trust me, I'm making your homework a little bit easier, and by next week, we get through, we should be done. I don't know. I told you I'm leaning towards no test or partner test.
Partner test. That's big. You want partner test? I don't know. I'll be no test.
I could probably be.
Can we all be Tessa's partner?
Yeah, can we all just like group up?
I know, I'm gonna make this a great test for you.
Katie, we do take a test with you.
Why do you want to be my partner? I'm confused.
So we have your partner.
Thursday, Friday.
I will only be here for part of Friday because we have races off.
Well, let's go
Perfect.
Friday.
Let's just not even do it. If Tatum, then what's the point?
That's a really good point. Alright, let's look at this one. Let's get through this because we can be done. Alright.
I'm going to be on Friday too. That's like half the class right there.
Well, let's get through this and you guys can have your time. And I won't have to be mad at you for doing stuff that off task. Alright, so we have to get used to this. This should be pretty. Dang it.
I wasn't even talking. I was just
Alright. Alright, so we have to do distribute our FOIL method. So I'm going to do 4 times 5 is 20. And then I'm going to do 4 times the square root of 2. You give me 4 times the square root of 2. Don't forget the second term is a negative number. So negative 2 square root of 2 times 5 is negative 5 times the square root of 2. And negative square root of 2 times square root of 2 is just negative 2. I look for my like terms. 20 minus 2 is 18. Can I subtract 4 times the square root of 2 minus 5 times the square root of 2? Yeah, they have the same base, that square root of 2. So 4 minus 5 is negative 1, or just negative square root of 2. lost some part of that?
No. Yeah. Maybe. Yeah.
Two lost it. 5. That's -1.
Yeah. Or, I mean, it's -1 times the square root of 2. Do I have to put the 1 in front of it?
No.
No. So that's just all I do. If you do, it's okay. Okay. On number 2, before I do any multiplying, I always simplify. Okay? I see in my numerator, I can make this x squared, the square root of x squared is just going to be x. So then I have
I think that's the time of it to go noodle, right?
yes. Alright. Okay. Times the square root of 5. Alright. How do I get rid of the square root of 5? And I would get oh, I don't know why they did parentheses there. You could. It's just I don't do it that way. Can I simplify anything? So we're done. Alright, so today is I will rationalize the denominator, I will simplify radical expression containing fractions. There's really not a whole lot difference on this. And we only have 5 questions we're doing. So make sure you follow along so you get this. All this is going to be about is simplifying. So to be honest with you, when I do this first one, there's lots of ways what do you feel comfortable with. But what would you do, Reagan? Or Reagan? Katie? How about Katie?
I'm an entirely different race than Reagan. How do you confuse that?
Don't you cover it. All right.
Oh my God.
I'm very
Okay.
I don't know
That's kind of creepy.
Yes.
You'd split 32 into 16 squares.
Man.
All right. So square root of 32 is the square root of 16 times the square root of 2. And so I'd go ahead and say square root of 16 is 4. So I'm going to rewrite my numerator now. My numerator is 4 times the square root of 2. My denominator stayed as 9. Now, is there anything else I can simplify?
No.
So you're done. Number 2 is one trick, and if I'm honest, I think it's on the next one I did. I did on number 1, the next one. Okay, do not forget that you have that 10 on the outside. Because what I end up doing is, I sometimes will forget about it. This means 10 times all this. So I'm going to first do square root of 9, square root of 5, and the square root of 9 is 3 times the square root of 5. So I'm going to write my answer here. And how do I get rid of that square root of 5? Oops, I wrote 3. So then I'd have 3 times the square root of 5 all over 5. Oh, that was
by 10.
And I now have my 10 there still. So if I have 10 times 3 times the square root of 5, but remember, when I have 10 times 3 times the square root of 5, I will get what?
10 times
30 times 10 times the square root of 5.
Yeah, because remember, this is all multiplication. All of these are multiplication, right? Commutative property or associative property, I can kind of switch them around. So I would just make this 30 times the square root of 5 all over that denominator 5. we would simplify. Okay, so what I did was we had our 10, right? And this is 10 times 3 times the square root of 5.
So you're not multiplying the 10 by the square root of 5. You're just multiplying it
Not
by
yet.
3.
Yeah.
Why can't you multiply by the root of 5?
Why what?
You have to multiply by the denominator too because it's outside of the equation. It has to be 50
So
on
then
the
I
bottom
could
because it's outside of the equation.
What?
Doesn't it have to be 50 on the bottom because it's outside of the equation?
This 10 means 10 over 1. Means I can put it in the numerator. I only take it times the denominator if it was 10 over 10. So then I simplified. 30 divided by 5.
6.
And my final answer is 6 times the square root of 5. Yes. Okay, you could. I think. Let me look at it again. Wait, square root of 5. No. We don't have a square root of 5 over square root of 5.
She's just saying that I can just 5.
Yeah, when you simplify it, you divide out the square root of 5.
The square, no, because think about what's the value of the square root of 5?
2 point something.
2 point something. What's the value of 5? So I can't say 2 point something divided by 5 is 1.
The only number you can do that with is 2.
Alright. Number 3 should have been very simple. How would I set up 3? What would I do? What do I times by? Square root of g. And so my answer would be
FG squared.
Huh? Alright, last 2. Guys, we are wasting so much time because we're off task. We only have 2 questions left. First thing I want to do is simplify as much as I can, so I'm going to focus on just my square root. So, my 3/4, I'm going to come back to and multiply that in a little bit. But I'm going to focus on the square root of 16 all over the square root of 27. What would you do first? What did you get for? Okay, square root of 16 is 4.
Take out 9 and 3.
27, we factor down to the square root of 9. Square root of 3. That becomes 3. So I'd have 3 times the square root of 3.
Wait, do you have to multiply by the square root? I know that because you can't have that on the bottom.
Wait, and multiply by 3 square root of 3. How about we multiply by 0.4?
Why? There's a good reason to do that.
You multiply 3
So-
times the 4 and 4 times the 3.
Listen, because this is important. Why would I want to go, why on this case especially, do I want to multiply by 3/4 right away? Because that's going to go into this. I still have to multiply the 2. Why would I want to do that right now?
Because it's the reciprocal. That's
The reciprocal. If I go ahead and I do 3/4 times 4 over 3 times the square root of 3, well, I can simplify right now. 3 to 3 is 1. 4 to 4 is 1. I'd be left with 1 over the square root of 3. So I have to do what?
Literally just
You have to times by that square root of 3. And we would get the square root of 3 all over 3. Okay, very last one. Simplify on our numerator first. What would the square root of 36m squared be?
6m.
6n. Square root of 36 is 6. Square root of m squared is n. Can I simplify anything on the denominator?
Yeah, so you take n to the second half and then move n outside.
So I would make that n squared and n. So I'd really have n, because that's what this becomes, and then times the square root of 10n. Okay. Where would you go from there?
You multiply 6 with n, square root of 10n.
Alright. Then I'd get 6m times 10 squared, and I'd get n. Are we adding? So we're multiplying. Am I done? So 3m square root of 10n. Anything else I can do to simplify?
No. No.
Cannot do the n's because that one's being square rooted. Which is pretty interesting. We got the same answer. I will say before, we're going to stop there, but I will say, just knowing when I did mine, I didn't do it this way. I simplified the square roots first. I did 36 and 10. It made it 18 over 5. So I just simplified that because they're both being square roots. I got the same answer. So that's what I'm saying. You have to do what you are comfortable with. All right, your homework. We're doing 7 and 8. I did find, I have these printed. I thought I did. Okay, I have the packets for this whole radical thing that we're doing, 5 through 11. So we are doing 7 through 8. Number 7 and 8. Number 7, there's only 5 questions. Okay, pay attention to this. This is what I'm changing. On number 7, lesson 7, you need to do all of them. There's only 5. For 8, go ahead and do evens. Because that'll give you 5, so we'll do a total of 10.